This problem here says, for the following exercises, use the graph of f to sketch the graph of its inverse. So the first thing to understand about the inverses is to understand about how this mapping works. So essentially, when I talk about inverses, I swap my domain and range. So what that means is, and you think of all the points on the xy plane that doesn't move. So let's say I take the point 1, 1. The point 1, 1 would stay 1, 1 if I swap the domain and range. So what I'm getting at here is everything on the y equals x line is not going to move. So every point on there is going to stay right there if I swap my domain and range. So that means for every point on my graph, so being here, is also going to stay in the same spot. So there's only one here. Now what's going to happen here is everything else is going to look like a reflection across the y equals x line if I do this swap. So what I mean by that is, let's take a look at this point down here, that point -2, 0. So that means that point is now going to be over here at 0, -2 if those swap. And then also this 1 here, that's also going to be here now when they swap, when I'm talking about the inverse. And then also on the other side up here, that's going to be here. So now, if I actually draw that line in there, that's exactly what I see about that reflection. So it looks like it reflected across the y equals x line, and that's what my inverse function does. And then we can see how this actually works. So now we're going to do the same thing with the next one here, with a number, doesn't have a number on it, but the one next to 195. So there's our y equals x line. I put that in first. And again, it's just like that mapping, just the same. So I'm going to use a red to represent that graph there. So this 0, 1 is now going to be 1, 0. So I'm going to put that here. Okay. See what else we can come up with here. And all I'm doing is looking at this piece right now. And then I also see that I can put this point in. I guess that looks like it's almost at the point -1, 2. So that would be -1, 2. So that would be 2, -1, almost -1. So that would be just slightly before it, almost on it. So that would be that point there. This kind of gives us a good feel about how this is going. And this looks like it goes out to 2 and up to 4. So this would be 4, 2. So that would be there. And then we notice here, we can actually draw this dot on there because that's going to be on the XY plane. That's not going to move. So then if we fill this in, we get this picture here. And if you look at this, it just kind of does the same thing. Oops, a little less, but that's the idea of it, because it should look the same, but on the other side. Now we're going to take care of this piece here. So again, you got to do two pieces that, they're different. Okay, so now we're going to look at the points there. So let's just try to find one that's helpful. This one here is 4, 0. So that means it's going to be 0, 4. That's going to be up there. And then it just kind of goes up until that point. So this is just going to kind of go up until that point. And that's what we see. So that's going to be the graph of the second one using the inverse, using the idea of the inverse function from a graph. So there it is. And I'll label these. Now remember, this is the idea of what it's called f inverse of x. Y equals f inverse of x. And the same thing here. Y equals the f inverse of x. So there's our answers for these two here. Just remember, it's that reflection across the y equals x line. And we just use that as our point of perspective to draw the graphs and realize, hey, this is the mirroring going on that we see, which is called a reflection.